ተመልካች አድማጮቼ ዛሬም እንደተለመደው አሪፍ ቪዲዮ ይዤ እንደምትወዱት እርግጠኛ ነኝ። አሁን ቪዲዮ ይመጣል። በደንብ አድርጋችሁ ፎከስ ወይም ትኩረት ሰጣችሁ ተከታተሉ። ለዚህ ቪዲዮ ደግሞ ሰብስክራይብ ማድረጋችሁን እንዳረሱ። ሰብስክራይብ ወሳኝ ነው። ኮሜንት ሐሳብ አስተያየታችሁን ኮሜንት ሴክሽን ላይ ጻፉልኝ። ላይክ አድርጉ። ለምትወዱት ደግሞ ሼር አድርጉ። አመሰግናለሁ። ሰብስክራይብ እንዳይረሳ።
Hello, I am Milka Jirle, working as Assistant Professor in Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. Today we are going to learn what is mechatronics and introduction to mechatronics. Let's see learning outcome. At the end of this session, learners will be able to recall basic definitions of mechatronics and understand elements of mechatronic system. Before going for the definition of mechatronics, there are various definitions which are quoted by many researchers. So today we are going to see few of them. The word mechatronics is composed of mecha from mechanics and tronics from electronics. Hence, the word is derived as mechatronics. The term mechatronics was first assigned by Mr. Tetsuro Mori, a senior engineer of Japanese company Yaskawa in 1969. So let's see the definitions quoted by various researchers. Harashima and Tomizuka, they gave the definition of mechatronics as the synergetic integration of mechanical engineering with electronics and intelligent computer control in the design and manufacturing of industrial products and processes. The next definition is given by Mr. Oslander and Kemp. They say mechatronics is the application of complex decision making to the operation of physical system. The next mechatronics definition is given by Mr. Oslander and Kemp. They say it is the application of complex decision making to the operation of physical systems. Mr. Shetty and Koch say mechatronics is a methodology used for optimal design of electromechanical products. Mr. W. Bolton gives the definition. He says mechatronic system is not just a marriage of electrical and mechanical systems and is more than just the control system. It is a complete integration of all of them. So these were the few definitions quoted by few researchers. Now let's see the key elements of mechatronic system. Figure 1 shows the key elements of mechatronic systems. This is the block diagram of mechatronic systems, where it consists of modeling, analysis, integrated system design and testing. So it consists of various mechanical systems, electrical systems, graphical displays and output signal conditioning and interfacing. So the actuators and sensors constitute of mechanical systems, whereas input signal conditioning and interface and digital control architecture constitutes of electrical systems. So here we see the graphical displays, LEDs, LCDs, digital displays and CRT. And in this block, that is output signal conditioning and interfacing, digital to analog converter, amplifiers, and the complete block is known as real-time interfacing. The mechatronic system is classified into 5 different categories. They are: first one is information systems, second one is mechanical systems, third is electrical systems, fourth one is computer systems, and the fifth one is real-time interfacing. Modeling is the process of representing the behavior of real system by collection of mathematical equations and logic. Models can be broadly classified into static or dynamic. Models can be classified into static modeling and dynamic modeling. In static modeling, there is no any effect of thermal changes or any force applied. The system is, the name itself indicates the system is static, whereas in dynamic all the properties, system properties are taken into consideration. Mechanical systems are concerned with the behavior of matter under the action of forces. Mechanical systems not only consist of machine components, it also consists of fluid systems, pneumatic systems, thermal system, acoustic and chemical systems. Figure number 2 shows the mechanical system components like rack and pinion, cam and follower, sprocket and chain, and slider and crank. So these are the examples of mechanical system components. So as we have discussed, mechanical system consists of actuators and sensors. Actuators produce or cause the motion. Actuators usually are electrical, mechanical, fluid power or pneumatic based. Actuators transform electrical inputs into mechanical outputs such as force, angle and position. Sensors detect the state of system parameters, inputs and outputs. Sensors are required to monitor the performance of machines and processes. There are various types of sensors and actuators present in the market. Figure number 3 shows the actuator, that is DC motor, and figure number 4 shows flexi-force sensor. There are various types of sensors like potentiometer sensor, flow meter, orifice meter, load cell, and n number of sensors are available. Electrical systems are concerned with the behavior of 3 fundamental quantities like charge, current and voltage, or it can also be called as a potential. Are concerned with the behavior of the 3 fundamental quantities. They are charge, current and voltage. The examples of electrical systems are resistor, capacitor, inductor, transformer and analog signals. The input signal conditioning and interfacing systems provide connection between the control circuits and input-output devices. The graphical displays of device produce visual feedback to the users. The real-time interfacing includes analog to digital converters, digital to analog converters, and signal conditioning circuits and sampling theory. The overall control of the system is carried out by digital controls. Figure number 5 shows analog to digital converter. Now, I want you to pause the video for few seconds and list down the various mechatronic systems that you come across in your day-to-day life. So let's see the few examples of mechatronic systems. Autofocus camera, robotics, washing machine, engine management systems, microwave ovens, camcorders, aircraft flight control and navigation systems, numerically controlled machine tools, photocopiers and barcode readers. So these are the examples of mechatronic systems. Like most of the home appliances, electronic home appliances are made up of mechatronics system, and the various robots. In the late 70s, the Japan Society for the Promotion of Machine Industry classified mechatronics products into 4 different categories, that is class 1, class 2, class 3 and class 4. Let's see what is class 1 product. Class 1 products, they are primarily mechanical products with electronics incorporated to enhance functionality. So the examples are numerically controlled machine tools and variable speed drivers in manufacturing machines. The class 2 systems are, those are traditionally mechanical systems with significantly updated internal devices incorporating electronics. The example includes modern sewage machine and automated manufacturing systems. Class 3 systems are, they retain the functionality of the traditional mechanical systems, but the internal mechanisms are replaced by electronics. The example is digital watch. Class 4 products, they are designed with mechanical and electronic technologies through synergetic integration. The example includes photocopiers, intelligent washers and dryers.
እሺ አድማጮቼ ይሄ ቪዲዮ እንደተመቻችሁ እርግጠኛ ነኝ እንደወደዳችሁም ተስፋ አድርጋለሁ አሁንም በድጋሚ ያው እንዳትሰላችሁ ሰብስክራይብ በማድረግ በማየት ሼር በማድረግ ተባበሩ ቪዲዮ እንደወደዳችሁም ደግሞ ያው ያሳውቃል ይሄው ደስ ብሏችኋል የሆነ ፈገግታ ነገር ይታያል ከፊታችሁ ላይ ስለዚህ ቀለቀጣይ ቪዲዮ ደግሞ ጉጉት እንዳላችሁ ያሳውቃል ለምን ሰብስክራይብ የምትለዋል ታች ያለችዋል ክሊክ አድርጋችኋል ማለት ነው አመሰግናለሁ